Hello everyone, welcome to lecture series on computer organization and architecture. We'll discuss lecture number 37 of module number 4. Contents covered in the previous lecture are cache memories. So cache memory is a technique or the architectural method that is used to increase the execution speed of the processor. That is, in order to achieve a good performance, so we are going to make use of an cache memory. So compared to processor, the main memory becomes a slower one. So hence, in order to increase the accessing of data or the instruction from the main memory, we are going to make use of a cache memory. So here the cache memory, it is a small fastest memory component that is included between the processor and the main memory. So here the cache memory is going to hold the information. So it is used to hold the information. It makes the feel to the processor that it is going to access the information very fast. So here in case of cache memory, we know that processor is going to perform certain read as well as write operation. So if at all the data is available in the cache memory, we call it as a read hit or write hit. And if the data is not available, if the data is missing in the cache memory, we call it as read miss or write miss. So with respect to write operation, we have two protocols. So one is called as an write back protocol and another one is write through protocol. So these concepts was discussed in the previous lecture. Contents covered in this lecture are virtual memories. So virtual memories is used when we want to go with the increasing size of the memory system. So cache memories are used for increasing the speed of the memory system, whereas virtual memories are used to increase the size of the memory system. So learning outcomes. After this lecture, the students will have a better understanding of virtual memory concept. So this is the Bloom's taxonomy pyramid. So in this lecture, we are going to understand the concept of an virtual memory. Hence, it is going to fall under the taxonomy level number 2. So now, before understanding a virtual memory, it is essential to recall the important challenge of a computer system. So computer system requires a large fast memory system at an affordable cost. So the main thing is that the memory should be a larger one and it should be a faster one, but the cost must be an affordable one. So hence, in order to achieve a large memory system as well as a fast memory system, we are going with an architectural solution. So in order to increase the speed of the memory system as well as to increase the size of the memory system. So in the previous lecture, we have discussed in order to increase the speed of the memory system, we have made use of a cache memory. So it is one of the architectural solution that is being developed in order to increase the speed of the memory system. So cache memories were developed to increase the effective speed of the memory system. So we have one more criteria, that is size of the memory system. So in order to go with the size of the memory system, that is increase size of the memory system, we can make use of a virtual memory concept. So again, virtual memory is an architectural solution which is used to increase the size of the memory system. So hence, cache memory means it works for effective speed, whereas virtual memory means it is going for effective size of the memory system. So these are the two concepts that are used in case of for achieving large and fastest memory. So in most of the modern computer system, we know that physical memory will be generating an addresses. So that is the processor will be generating an address. So depending upon the address, so we can say that many number of memory locations can be accessed. So that is in most of the modern computer system, the physical main memory, it is not as large as the address space spanned by an address issued by the processor. See, processor will be issuing an address space, but actually the memory will not be available with respect to that much address space, including that much of address space. Let us consider one example. Assume that the processor is having a 32-bit addresses. So if a processor is having a 32-bit of address lines, then automatically it can fetch 2 to the power of 32 number of memory locations. So that is addressable space will be 2 to the power of 32, which is equal to 4 gigabytes. But actually the size of the main memory may not be a 4 gigabytes. Say for example, it might be a few hundred megabytes to 1 gigabytes. So the size of the main memory for a typical computer, it may be ranging from few hundred megabytes to 1 gigabytes. But the processor is capable of addressing up to 4 gigabytes. So hence here we have a mismatch in the size. So therefore, if with respect to 32-bit processor, 32-bit address lines processor, we know that it can generate up to, it can access up to 4 gigabytes of the address space. So now if I consider a program to be fitted in the 4 giga size of main memory, so obviously it is not possible to place that much of program in 1 gigabytes of space of main memory. So hence it is required that part of the program needs to be fitted in the main memory, and remaining part of the program obviously it needs to be stored in the secondary storage devices, say for example magnetic disk. So whenever it is not at all possible for a program to be fitted in the main memory, then part of the program can be fitted in the main memory and remaining part of the program can be stored in the secondary storage devices such as magnetic disk. So now anyhow all the parts of the program has to be brought to a main memory if at all it needs to be executed. So if we want to execute the program, then automatically it is essential to bring the it is essential to store the program into the main memory. So now if the space of the main memory is smaller, then we cannot fit a complete program in the main memory itself. Hence we have stored part of the program in the main memory and remaining part of the program in the secondary storage. So now whenever a memory is full, it is essential to bring the remaining part of the remaining part of the program which is available in the secondary storage to the main memory. So that's why a part of the program which is already, say for example if it is already executed program we have, that can be removed from the main memory and a new part of or new segment of the program can be placed in the main memory. That is, the second point says that when a new segment of a program is to be moved into a full memory, it must replace another segment already in the main memory. So in most of the modern computers, operating system is going to do this job. That is, it is going to move the program and data automatically between the main memory and the storage secondary storage devices. So thus application programmers need not be worry about these operations. So that is regarding the limitations imposed by the main memory. So here the limitations of the main memory is, we are going to split the program and we will be storing it in the main memory and secondary storage. When the secondary storage part of the program which is available in a secondary storage program needs to be executed, obviously it needs to be brought from secondary storage to the main memory. So during that time a segment of a program has to be removed and a new segment from the secondary storage has to be placed into the main memory. So these transferring of program and data from secondary storage to main memory, it is done by the operating system, and it is all the that is the headache of the operating system, and application programmers need not be worry or aware of all these limitations which was being imposed by the main memory. So here the techniques that automatically move the program and data block from the secondary storage into a physical main memory when it is required for execution, and such technique we call it as a virtual memory. So that is automatically moving this information whenever it is required for execution. So that technique we call it as a virtual memory techniques. So here, so we have a programs and the processor references and instruction and data space. that is independent of the available physical main memory space. So we know that the processor will be generating the addresses. So by using the total number of bits in the total number of address bits, the processor will be generating an addresses. So the address generated by the processor, normally it will be a binary address. So the binary address that is being generated by the processor, it is normally used for accessing the information like instruction or data. So in order to access the information like instruction or data from the main memory, the processor is going to generate an address. So that address we call it as an virtual address or logical address. So this virtual or the logical address needs to be translated into physical address. So here virtual or the logical address will be generated by the processor in order to access the instruction or the data. So that has to be converted into the physical address. So converting the virtual address or logical address to a physical address, it is done by the combination of hardware and software components. So both hardware and software components are used in order to make a conversion of virtual or logical address to a physical address. So here, if the virtual address refers to the part of the program or data space that is currently in the physical main memory, then content of that appropriate location in the main memory are accessed immediately. So no doubt virtual address will be generated and it will be converted to a physical address. So if that address location is available in the main memory, that is the content program or the data, if it is available in the appropriate location in the main memory itself, then we can access it immediately. If the reference address is not available in the main memory, then obviously it needs to be brought from the suitable location into the main memory before they are being accessed. So here the data or the instruction may be available or it may not be available. If it is available, it can be immediately accessed. If it is not available, it must be brought from the suitable memory location into the main memory before they are going to get accessed. So here we have a virtual memory organization. So here there are certain components like processor, we have a cache memory, we have a main memory, and we have a disk storage. So here the process in between processor and the main memory, we have a cache memory. So this cache memory is used to increase the speed of the processor, means increase the speed of accessing the instruction or the data, hence it is going to give the good performance. So here the cache memory is placed in between processor and main memory. So any data that needs to be transferred from processor to main memory or from main memory to processor, it will be available in a cache memory. So cache memory included in order to increase the speed of the execution. So now we have as we are discussing a virtual memory, so here the processor will be generating an address. So the address will be in the form of a binary one, so depending upon the address lines. So that address we call it as a virtual address or logical address. So this virtual address or logical address needs to be converted to a physical address. So the conversion of virtual address to a physical address, it is done by MMU, where MMU stands for Memory Management Unit. So memory management unit, it is a hardware component that is used to convert virtual address into a physical address. So once the conversion is done, it will be checking for the data availability or the instruction availability in the cache memory or in the main memory. So if the data is available, it will be immediately passed to the processor. If at all the data or the instruction is not available or that particular memory location does not exist, then it needs to be accessed from the secondary storage device. Here the secondary storage device is a disk storage or hard disk. So it will be brought from the secondary storage to a main memory. So here the transferring of the data from secondary storage to main memory will be done by using a DMA mechanism. So this is the virtual memory organization. MMU is the main component for conversion of this particular address. So here virtual memory concept is used in order to increase the size of the memory system. So here Figure shows the typical organization that implements the virtual memory. As I told that we are going to make use of a special hardware unit called memory management unit, wherein it translates virtual address into a physical address. So when the desired data or the instructions are in the main memory, then those data or instructions can be fetched immediately. If at all the data are not in the main memory, then the MMU causes the operating system to bring that data from the hard disk to the main memory. So memory management unit makes an operating system to get the data from hard disk to the main memory. So this transfer of data from hard disk to main memory, it is performed by using a DMA mechanism. So DMA stands for direct memory access. So direct memory access means without involving the processor, the data is transferred from the hard disk to the main memory. So here at that time we will be using an MMU unit. So MMU unit makes the means it will be generating a actual physical address. So in order to identify the availability of the data. So conclusion is we have discussed virtual memories in this lecture. So virtual memories is going to increase the size of the memory system. So with the help of memory management unit, we can make a conversion of the address that is being generated by the processor, that is logical address or virtual address, to the physical address. So whenever it is not possible to fit the entire program in the main memory, then part of the program can be placed in the main memory and remaining part of the program can be stored in the secondary memory. So whenever it is essential to execute the program that is stored in the secondary memory, it needs to be brought to into a main memory by replacing certain part of the program from the main memory. So this is regarding virtual memories. Thank you.